Hi, I'm Matt Traverso. I'm the editor for a new project at the OIF, leading an investigation and ultimately a white paper on a high-density connector that changes the existing connector paradigm from a 1D connection to a 2D connection to enable much higher density and enable the next generation 448 gig signaling for AI and other large-scale compute applications. What's critical for such a connector is maintaining great signal integrity, maintaining a really lossless and discontinuity-free electrical channel. This is critical to have the most power-efficient signal processing and the most faithful signal and power integrity across the entire link. This becomes much more critical at 448, where the bit times now are becoming so short that it becomes very challenging to distinguish between a 0, 1, 2, or 3. So our job is to define this connector and make it such that it can enable the next generation connectivity. One of the things that we are also focused on is making sure that the density of this, both from a footprint point of view as well as from a thermal point of view, is reasonable and can accommodate these next generation data centers and the warehouse scale computers. We're really focused on power efficiency. There's been a lot of press lately around the high power consumption of these large scale data centers. So the more we can invest in making better signal integrity, the better power efficiency we will get for these next generation links.